Hi everybody, hola y buenos días, and welcome to my presentation. Thanks for coming. So my name is John, and I'm an iOS developer at Hyper. Hyper is a Norwegian digital agency where we build apps for customers, as well as some of our own projects as well. But what we try to focus on is to build like really nice visual experiences that are sometimes companion apps to some form of campaign that some of our customers is running. So over the last couple of months, I've spent a lot of time working on animations. And I must say, I really love animations. They're so much fun. In fact, you can start counting, but this talk alone contains over 100 animations. So I think we're going to have a lot of fun today. So what I want to do today is share some tips and advice and just some learnings over how to build animations for iOS. And of course, there are so many great tools and prototyping things you can use and libraries, and we won't have time to cover all of them in this talk. So what I wanted to focus on is to simply talk a little bit about some techniques and tools that I found to be really, really useful, and things that are kind of built into the system on iOS that we can use out of the box. As well, to talk about the workflow aspects of animations and how we can actually become a better team together by working with animations together with both design and development. Because that's kind of why we're all here, right? To get better understanding of both these disciplines and how they can work together. And especially when you're talking about animations, I think this kind of teamwork is especially important. Because animations, they require a lot of tweaks and iteration. You can't just design something in Sketch or Photoshop and then just expect it to work on a device. Because you need to see the animation running, implemented using real code, until you know that it's just right and just great. And that requires a lot of iteration. You have to go a lot back and forth. So it requires us to set up really nice and smooth workflows that enables us to go really quickly between our asset creation process in apps like Sketch or Photoshop, or maybe we're using After Effects or something else, and go into the code that we're then shipping in our app. But of course, it's important that this workflow doesn't only go one way. We also want to make sure we have good feedback coming back so that it's easy to tweak and iterate and come up with new solutions to problems. So today we're going to talk about some of those tools and techniques that I've found to become really useful when establishing these kind of workflows and how it can affect our jobs both as developers implementing animations and as designers designing animations. Now, I'm a developer, so of course I like to get into the details. I love to talk about how things are made. So we're going to talk about that a little bit today, but we're also going to talk about the processes themselves and the tools as well. So let's get started. When it comes to animations, I want to talk about three kinds of animations. I want to talk about scene-based animations, where you're rendering more or less an entire scene that maybe captures the entire screen. That could be something like an onboarding flow, where you have some animation to explain how your app works. Or maybe you just want to delight your users with something charming, like a little character that gets animated, or something that captures the screen. Of course, the most common animations that we work on are view-based, where we take an element on the screen, like a label or a button or an image, and we move it around somehow. We scale it or rotate it or fade it in and out. So we're going to talk about those as well. And we're also going to talk about frame-based animations, which is something we use a lot as well, where you create these images, like a sequence of images, that you animate over in sequence. So to get started, I want to show you an example. So one app that we worked on recently at Hyper was an app for a Norwegian company called Diplomis. And Diplomis, they're a ice cream company. They're making ice cream. And they've been working for many, many years in Norway. They're only there as far as I know, so I'm not surprised if you haven't heard of them. But they're selling ice creams in stores and in markets and all over the place. But they launched this new campaign this summer where they're actually taking these trucks and they're going out directly to customers to sell them ice cream. And I think that's pretty cool, right? They're going out into the neighborhood, playing a little jingle. The kids come out and buy some ice cream, and it's all good. And you can see here that this picture here was clearly taken on the one sunny day in Scandinavia. Because it's not Barcelona. We don't have this kind of weather every day. So we wanted to make an app that was like a companion to this campaign, where the users could sign up to get notifications to see when this truck was coming to their neighborhood. And when we started working on this app, one of the designers on our team had a pretty cool idea. He thought, what if we make this app have a little character inside of it that you could follow along? That would make it a little bit more charming and a little bit more fun. So what should we pick the character? Well, the obvious choice would be to pick the character from their logo, like this Eskimo. But we chose a different approach because this campaign was all about the trucks. We actually chose to make the truck the main character. So here you have an animation that you see when we open the app, where we see the truck. He's standing right outside the factory, asleep. There's like a little Zeds coming out of the horn. You know, you get introduced to like, this is the truck, and this is what this app is about. And then you can select your neighborhood, and then you see when the truck is going to arrive in your neighborhood, and then things start to happen. Then this truck starts moving. You can see the city flying by in the background. You can see the car jumping a little bit, and the wheels are turning. And we get a lot of animations going here at the same time. So I want to talk you through how we actually built this animation and what kind of tools that we used. So when we started looking into this and we came up with this idea, we researched a couple of different tools and techniques that we could use. And we wanted something which was really high performance because we wanted to render all these things really smoothly at 60 frames per second. We wanted something which we could add a lot of detail and different objects without dropping frames. So what we eventually settled on was to use Sprite Kit. And Sprite Kit, for those of you who are not iOS developers, it is Apple's 2D framework for game development. And now you might think, game development? Well, that sounds crazy. I mean, we're talking about an animation, not a game, right? But it turns out that when you're building animations, there's so much we can learn from game development because they're facing so many of the same challenges that we're facing when we're building animations. In a game, you want to make sure that you're always rendering smoothly at 60 frames per second, or on the new iPad, even 120 frames per second. You want to make sure you don't drop frames, because that could lead to a very jarring experience. And we've probably all played these games sometime where things were lagging, and it was dropping frames, and it didn't look good. So modern game engines, they have spent a lot of time optimizing for that use case, to making sure that even if we add lots of objects to a scene, we're still rendering smoothly. So this is a great tool, actually, to use for these scene-based animations where we're capturing the whole screen. So doing this animation in Sprite Kit, it means to create a scene for our animation. And Sprite Kit calls that an SK scene, SK for Sprite Kit. And then we can add all these objects to the scene. In our case, it was the houses in the background that are moving with this parallax effect. We have the car, and then we have all the different parts of the car, and even the sun as well. Those can all be added to the scene. And Sprite Kit calls that Sprite Notes. Now, a sprite is really just a game developer term for an image. So it's just a node that renders an image at any given time. And you can change that image and animate over that if you want as well. Now, what was interesting with using this technique was that if we take a closer look at the car for a moment, we can see that we actually split this car up into multiple pieces. So the car itself consists of the wheels that are individual elements, as well as the window, because if you notice in the previous screen, you could actually see that we animate the window in of its own. You can see the sun, the reflection of the sun, moving in the window. And that might seem like one of those things that, why spend time on that? But it turned out actually to be really easy thanks to this approach. So the cool thing is that we have these different parts of the car, and then we can contain them in a node itself because we have a hierarchy. So nodes can contain other nodes. And that's pretty nice, because that way we can move this car around, we can animate it, without having to do it individually for all these different pieces. Now, what was really important to us when we started out with this was to have a really nice workflow between both design and development. So we made sure from the beginning that the hierarchy of this car here in the code matched the hierarchy that we used in the sketch file. This was really important because that allowed us to super easily export new assets from Sketch without changing our code. So we could easily just drop new images in and everything would just work. And that is because of a system that Sprite Kit calls Texture Atlas. Normally, we are very, very aware of building these animations or elements that have so many different pieces because it can hurt our performance. In the early days of mobile development, probably all of you who work on design or something like that got taught that you should always bake everything into a single image. If you have shadow, bake it into the image because it's going to be much faster. But because Sprite Kit has this system called Texture Atlas, it can easily actually combine images into a single texture and render them using a single draw call. We can do that while still using individual images. So it means that our workflow as both developers and designers doesn't have to get more complicated. In fact, it's super easy, but we still get really good performance. So what we only have to do is to drop our assets inside of this magical folder called a .sprite atlas folder. And it's a normal folder on the file system, so anyone can drop things into there, and it will automatically be included in our texture atlas. So let's jump back here and take a look at this animation again. We can see that there's quite a lot of things going on here. You know, we have individual animations for the truck, we have the individual animations for the wheels, and for the city flying by in the background using this parallax effect. So how did we actually create all of these animations now that we added these nodes to our scene? Well, for that, Sprite Kit uses an action metaphor. What that means is that all of the animations we want to perform, we describe them using actions. And this turns out to be a really nice metaphor when it comes to working with animations. Well, let's take a look at how we animated the car. So I'm going to show you some code now, but I think that even if you're not an iOS developer, you will find it quite easy to read. So let's take a look at how a jump action works. So the jump action is really just a sequence of two other actions. We're just moving up by 3 pixels on the y-axis, and then we're moving down again by 3 pixels. So we create this little jump effect, up and down. And then what we do is we take this jump action and combine it with a wait duration for 2 seconds. That means that the car is going to continuously jump every 2 seconds. And that's because we tell Sprite Kit to run this action on the car forever. So every 2 seconds, the car will jump up and jump down. Very, very easily. And this is actually the real code that you use for this type of animation. Super easy to read and very easy to use as well. The same thing goes for the car, or for the wheels. The wheels, they're also jumping, so we can reuse the same jump action in our wheel action. And then we have a little rotate action there as well that we also run forever. So here you can see that we get a very nice overview of what's going on in our animation. We can move things around, we can tweak them together between design and development, and we can get a sense of what is happening very, very quickly. So Sprite Kit was really great for this type of animations. It enabled us to create these really large, complex standalone scenes without any problems. It was easy to compose these actions and to build these animations from them. And we could also reuse actions quite a lot. As we saw, we reused our jump action from the car itself into the wheel. And we could create hierarchies that matched our asset structure that we used in apps like Sketch or Photoshop, because we could easily just import them using this Sprite Atlas. But of course, we can't always build animations this way. Not all animations are these full-screen, scene-based animations. So I would definitely not say that this is a silver bullet that you can use for all your animations. In fact, when we're building view-based animations, we need to take a different approach. So, like I mentioned in the beginning, a lot of the animations that we do on a daily basis in our UI are view-based. We have buttons, we have labels, we have images, we want to move them around, we want to change their size, fade them in or out, etc. So normally, the way we do this on iOS is by using code that looks like this. Now, this is okay, you can probably read this no matter what your skill level is, because you can see what we're doing is we take a button, we change the frame of the button, we change the size, and we change it to 200 by 200. So basically, when we run this animation, this button is going to get larger, right? So that's fine. I mean, for animations like this, that's cool. We can easily change it. We can easily work together on it. No problem at all. However, once we start to add more steps, because most animations that we do, they're not just a simple resize. In fact, if we just add a simple fade-in animation to this, the code starts to become a lot more complicated. This here, if you're not an iOS developer, is probably hard to understand. And to be honest, I've been doing iOS for a long time, but even I think it's hard to understand. It's hard to reason about, and it's hard to change. Say someone comes over to your desk and says, how about we change this fade-in animation? Maybe we remove it or we tweak it. It's going to be hard to just do that on the fly, and this breaks our workflow. We want to have a smooth workflow where we can do things quickly. So I think we can do better. We don't have to do our animations this way. But if we think about it, what are we really trying to do here? Well, we're really just transitioning between different states. We have a button, it is hidden from the beginning, then we make it visible by fading it in, and then we make it larger by sizing it up. That's really all that we wanted to do. And if we think back in the previous section where we were using Sprite Kit, we could actually see these things happen in the code very easily because we were using this action metaphor. What if we could do something similar, but for view-based animations as well? What if we could write code that would look like this? It kind of almost looks a little bit like pseudocode. It looks like it's something you're sketching out as a prototype. But this is actually now real working code, where we just tell the button to fade in with a duration of 0.3 seconds, and then scale to a size of 200 by 200 for a duration of 0.3 seconds. It's something we can easily read and reason about and have a conversation around. And same thing here, we can delete things, we can move them around, and this gives us a lot more flexibility in our workflow. So now you see this, you might think, okay, so that would be great, but this is not built into iOS. This is not something we can just use. So does that mean that we're going to have to get some library from GitHub or something and put it in our app, or use some really complex solution? It kind of sounds a little bit like we're trying to re-implement Sprite Kit, but for view-based animations. But the good news is, it's super easy to get something like this going. In fact, I want to show you all of the code that you have to write in order to make this happen right now. And before you worry, designers, and all the people who are not iOS developers, it's only going to take 2 slides. All right, so bear with me. We're going to enter dark mode here. That means that we're going to get nerdy. All right, so let's go. Let's go. Take a deep breath. All right, let's go. So the first thing we need to do is we need to create an animation structure. This animation structure will just contain the duration of the animation and a closure, which is what we call, which is like a function that gets run on the view that we want to animate. All right, so that's step number 1. Step number 2 is to create actual animations. So we create an extension on this animation structure, and we create one function for getting a fade-in animation, which just changes the alpha of the view that we're animating. And we create a scale animation function that just changes the size of the frame of the view we're animating. So far, so good. We're halfway through. All right, next slide. Here we can see where the magic happens. So here we create an extension on the UI view class, which is what iOS uses to render all of the user interface, where we create an animation function. So let's walk through this. Well, the first thing we have is we have our exit condition. This is what we're going to run when the animation is over. So when we have an empty animation array, then we just exit. We're done. Then what we then do is we take out the next animation that we're going to perform, and then we perform that one by calling this closure. And then when we're done, we recursively call this method to keep the animation going until we're done. I'm going to post this code later, so don't worry if you didn't get a picture of it, if you want to use it in your app. All right, let's get out of the nerd zone and let's get back to the fun stuff. All right, so let's say we wanted to build an app called iHungry. You know, back in the early days of iPhone, everything was called iSomething, right? iCompass, iDog, iWhatever. This app is going to revolutionize the food market. It's called iHungry, and I'm going to share it with all of you here today. What it enables people to do is just tap food and you get it delivered. I haven't really figured out the delivery part yet, but we'll see. We'll get there. All right, so what can the user do here? Well, the user can click on any food that they want, and then what we want to do is have a little animation which simply takes this food item and moves it into the basket. Now, which item is the user going to click? Well, of course, they're going to click the burrito, right? It looks so nice. Like this burrito emoji, I just get hungry every time I see it. All right, so the user clicks on the burrito. What happens? Well, the burrito flies over to the basket, and a little 1 pops up to show that we now have 1 item in the basket. All right, that was pretty quick, so let's take it in slow motion. Let's go back and reset the state, and let's take a look at how this works. So the user's finger comes in, and clicks the burrito, and then the burrito moves over, fades in, and the badge pops up. Pretty cool animation, I think. And that kind of shows also the user what's going on. The item moves to the basket, and the basket gets incremented, right? So how did we actually build this animation? Well, now that we have this super nice API that we just built using this super simple code, we can actually construct these animations very easily. So let's take a look at all the steps involved. Well, first of all, we have to say to the burrito to scale up a little bit because we want to signify that this thing is going to move. Move it over to the basket's position with a certain duration, and then that's done. Then we want to run 2 animations in parallel, where we just say that this burrito should scale down to 0.5% or 0.5 times its original size, and then fade out. Right? So then the burrito has scaled down and faded out. And then we want to animate the basket. So we want the basket to pop up like this. So what it's going to do is to scale up to 1.5 times its size, and then scale down again to its original size. And then finally, we want to fade in the badge. So we tell the badge to simply fade in with a duration. And that's it. And this is pretty cool, I think, because we can now actually read our animation code. Imagine doing this using the normal animation APIs. It would be like nested code with nested code with nested code. Someone comes over to your desk and says, how if we remove this scaling animation from the burrito? Well, you would have to pretty much rewrite a lot of your code and tell this person, please come back in 1 hour when I've changed everything. So it becomes hard to change our mind. So what I'd like to do now is to actually show you a quick demo of how it's like to work with animations using this way. So I'm going to go over here and switch over to Xcode. And we can see it. That's great. All right. Cool. So here I have the same animation code that we just saw in the slides. And if I run it here now, we can see what's going to happen. We're going to get our iHungry app there, and it's going to move over and play this animation. This is using a tool in Xcode which is called Playground. And I can really recommend to use that when working on animations together with a designer and a developer, because you can sit down and write your code in an interactive way. So what we can do now, for example, is that let's say that we come up with an idea that, you know, this animation is quite long. We would want to make it simpler. So let's say we want to take out the initial scaling animation. So what we're going to do, because it takes quite some time, so what we're going to do is going to simply comment this out here, which means that we don't use that. And then this playground is automatically going to refresh. We have to just wait, be a little bit patient, and then we see it's just moving over now. So the animation is a lot simpler. But now we maybe think, well, maybe it's a little bit too fast. Like the user doesn't really see that the burrito is moving. It's too quick. You know, and no one wants 2 quick burritos in their life. It's too dangerous. So let's increase this animation instead to 2 seconds and do the same thing. And again, I'm just waiting a little bit, be a little bit patient, and then the things are going to refresh, and we're going to see the results of our work. And we can now see the burrito moving over in 2 seconds instead of 0.3. And I think this is a really nice workflow, because this enables you to cooperate much easier and to change things. Because like was said in previous talks, was that you don't, as a developer, want to be this person who is limiting people's imagination. You want to do the opposite. You want to enable people's imagination. And by building these simple tools for yourself, you can make sure that you can enable people's imagination, and we can change things easily. All right, so let's move back to the slides. There you go. All right, so now we've talked about 2 kinds of animations. We've talked about view-based, and we've talked about scene-based. Let's talk about the third kind, which is frame-based animations. So this is something that you would normally use if you're building, for example, a custom loading spinner, which is shown when you're loading some data, or you're showing some kind of image animated over a sequence of time, or you're animating some kind of character or something like that that you want to show. Maybe some arrow indicating you can click over here or something like that, something custom. So for that, we usually use frames. And there's no shame in doing that. I mean, a lot of time now we're talking about all the animations should be data-driven, and there should be complicated views. Sometimes a sequence of PNGs or an APNG is the easiest tool to use. So that is actually something that I use quite a lot as well. So in my spare time, I actually work on some games, because I really love games, and it's a lot of fun to work with them with me and my friends. Unfortunately, I can't really do games myself, or it's not unfortunately because I love working with my friends, but I have a really, really good thing there because I cannot draw whatsoever. I need my friends to draw all the graphics for me. So what they do is that they create these nice little charming characters that I can then put in the game. And I do that by specifying the animation that I want to render. So I use this animation structure, which contains the name of the animation, the number of frames, and the duration. So it's quite simple. We just specify that, and then we just animate over that. So in the beginning, when we were working on these games, I was actually constructing these kind of animations by hand. So what would happen, the workflow, would be that the designers, they would create the animations, like the PNGs. They would put them in a folder, and then I would look at that folder, and I would count 1, 2, 3, 4, 5, 6, 8 frames. And then I would ask them, what duration do you want? Oh, 1.12 seconds. OK, great. I'm just going to put that in here. And that worked OK for a while, but then we started adding more characters to the game, and then we started adding more animations to the point where we actually have over 100 animations in this game we're working on. So doing this back and forth all the time, like how many frames, what duration, how many frames, what duration, it took a long time. And it was really frustrating, and it didn't enable us to move as fast as we wanted to. And it also acted as kind of a limiting factor, where sometimes more frames would be added to an animation, but I wouldn't update it, and we could forget about it. So this was something that we clearly could make better. So what was the problem? Well, like many other projects I've worked on, we had this graphics folder, or you can call it assets or images or something that you have in your app. It was just full of images. It was just all the images, all the graphics that we have in the entire app, which is contained in one folder. And it was a mess. It was really hard to work with, and it was really hard to see what kind of graphics we had. And this is something that is super common that I see in all the kind of projects I've been working on, where you have these like kind of messy folders that just contain lots and lots of assets. So the first thing we started to do was clean things up. We started moving things into subfolders where we could actually see that this is the graphics for the swordsman, this is for the moving animation, and this is for the right direction, right? He's facing right. So we could add that. And then we could actually simplify our naming convention so much. This is again something that sometimes we battle about between what kind of naming conventions are used in Sketch or Photoshop and what naming conventions we have to use in the code. Well, here it became super simple. We just took the index of the image. So frame number 0 is frame number 0. Frame number 2 is frame number 2. Super easy. And then we could do something really interesting. Since this was now self-contained in one folder, we could actually add a little text document to this folder, which we call duration. Now, this was not a super complicated config file with like some crazy code in it or something like that. No. It was just a simple value. In this case, the animation duration for the animation. So just the number 1.12, which is how fast we want this animation to go. So we did this, and we cleaned things up. And then we went back to take a look at this animation configuration that we had from before. And we could see that we had some interesting details here. Well, first of all, the name of the animation could now simply be the folder path. That way, we had a one-to-one map between the folder structure, the asset structure we were using when we were creating our assets, and the code, which again enabled this smooth, nice workflow. An also interesting thing was that the frame count was now simply the number of images that was contained in this folder. Because we didn't have this messy folder anymore with thousands of assets that we didn't know how they belonged together. We just had all the frames for one animation inside one folder. And then the duration was now in our duration text document. And if you take a look at this now, you will soon realize something, that all this information that we need is actually available right on the file system. And this is super powerful, because the file system is something all of us know how to use. So it's not something that requires a lot of domain knowledge. It doesn't require us to tweak a lot of complicated code or settings. We can just put files and folders in the file system and have it work for us. So how did we integrate this kind of workflow? Well, what we did was that we wrote a simple script that what it did was simply iterate over all the characters that we have in the game, and then iterate over all the folders that those characters have for graphics, and then generate this animation code that we needed right from the file system. And this enables us to do really nice stuff where we could just have everything be dynamically generated from the file system. So we can drop a new file, and everything will just update. Here's an example of how that will work. So here we have the same folder from before, where we just have 8 frames and a durations.txt. Let's say that the designers now are getting like creative and they came up with a new frame that we could add to this animation to make it more smooth. Well, what do you have to do? You just drop the frame in and everything will work because the code will automatically get updated to be 9 frames instead of 8. And the same thing, you could change the duration txt, you can move things around, and everything will just update automatically. So what have we been talking about today? Well, we've been talking about workflows and how we can enable smooth workflows between design and development when it comes to building animations. How we can pick our tools and set our tools up so that they're not making hard assumptions about a single animation, but they're rather more dynamic and easier to work with and easier to change. We've organized our project in a nicer way to enable anyone to actually easily change things by just dropping things onto the file system. We've started using some lightweight config files, not super heavy with code, nothing crazy, but just put values on the file system that we need to use for our animations. And then we've utilized scripts to automate things, so we don't have to have one developer full-time employed to just update assets. So we don't have to have frustrated designers who don't get their asset into the app because the developers were busy fixing bugs or something. We have everything automated in a super nice way. So what's the point of all of this? Well, in this room here, there are 2 distinct groups of people. There are also some other groups of people, but the majority are either people working on Sketch or Photoshop or other kind of design tools, or people working on code, building the actual apps that the assets will be used in. What are we looking for here? We're not looking for getting designers to become developers or getting developers to become designers. But we're looking to establish a workflow that enables people to easily just jump around and be able to change things quickly without requiring you to learn a completely new skill set. And I think that can be really powerful with when creating animations, because I think that great animations, they come from when people work together and iterate. So that's all I had for you today. If you want to keep in touch, I'm on Twitter. I'm @Sundell. I also write a weekly blog about Swift development, where I'll be sharing a lot more of these code samples and things from the talk today. And feel free to ask me any questions that you have, and share with me what your favorite techniques are for building animations. Thank you very much. All right, so now I'd love to answer any kind of questions that you might have. Yeah, there's a question over there.
Do you really believe the code is that easy?
I do.
For a non-designer to take on, honestly?
I do, yeah. I think that I'm not saying that the code needs to be so that I can just give it to a designer and they will just read it. But I think it needs to be in a way that we can have a conversation about it, where we can sit down and I can show you, okay, here's how this works, here's how this works, and we can actually read it like English. It's not like some weird form. That's why I think it's super important that we have our animations be specified like fade in, scale, fade in, scale, right? You know, like it's common terms.
Simplified, right?
Simplified, yeah, because I think that so many times we optimize things for being clever, and being smart. Well, I think we should just try to optimize it for conversations that we need to have in our teams on a daily basis. Yeah.
Thanks.
Hello, thank you for the talk. I was wondering, the Xcode Playground slide you showed us, is it actually playgrounds from Xcode, or is it a kind of plugin or something?
No, that's built into Xcode, so every iOS developer has it on their machine installed.
Then how do you share code between your real Xcode project and the playgrounds, because they don't interact?
You can just drop things in, and if you have, for example, your code in a framework, you can just drag and drop it in. Otherwise, you can copy over the code that you need into the playground and work on it. So in this case, I had this food view that I just put in there, and I could just work on the food view.
Okay, thank you.
Yeah, you're welcome. Nice. Any other questions? All right, feel free to, if you see me on the conference, feel free to come up and ask any question that you might have. I'm super happy to talk to you. Muchas gracias.